Good day everyone. Today we will see one sum in definite integrals which will contain many properties and some log rules also. Actually this is a textbook sum in NCERT. Let us see that sum now. I is equal to integral 0 to pi log 1 plus cos x dx. Let us mark this given sum as 1. Okay. Now I am going to use the property integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Because if I use that property, I will get cos pi minus x is equal to minus cos x. Okay. So now I will write again. My I will now become integral 0 to pi log 1 plus cos pi minus x, right? So dx. Now you know cos pi minus x is equal to 1 minus cos x dx. Let us mark this as 2. So usually whenever we use this property integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx, we used to add that 1 and 2. Let us add 1 and 2. We will add now 1 and 2. So what will we get now? 2i is equal to integral 0 to pi log 1 plus cos x plus log 1 minus cos x dx. Right? Now you have to remember some log rules. You know log a plus log b is equal to log ab. So now I will get this is log a, this is log b. So I will get integral 0 to pi log 1 plus cos x into 1 minus cos x, which is 1 minus cos squared x dx. You know 1 minus cos squared x is nothing but sin squared x. So I will get log sin squared x dx. Now I am going to make use of another log rule, that is log a power b, that will be equal to b log a. Here you have sin squared x. What is that actually? It is sin x the whole square. So a is sin x and b will be that 2, that square. So now I will get here 2i is equal to integral 0 to pi. I will get that 2 here, b 2 log sin x dx. This 2 let us take outside the integral. So you will get log sin x dx. Let us cut these 2 and these 2. So we get now I is equal to integral 0 to pi log sin x dx. Now there is one important example sum in your textbook, if you remember, integral 0 to pi by 2 log sin x dx. So I want to try something. I have here 0 to pi. So let me try whether I can get that 0 to pi by 2 log sin x dx, so that I can use that proceedings and I can proceed further. So now I am getting now I is equal to integral 0 to pi log sin x dx. So now I want to use the property integral 0 to 2a f of x dx is equal to twice integral 0 to a f of x dx. When is it possible? If f of 2a minus x is equal to f of x. I am going to see now whether this property will apply here. So what is my 2a here? In the place of 2a I have pi, right? Now my f of x is log sin x. So now f of 2a minus x, that is log pi minus x, is equal to log sin pi minus x. You know sin 180 minus theta is sin theta, because that is in the second quadrant and sin theta is positive. So now you will get this is equal to log sin x, which is your f of x. So now you have proved this condition, that is f of 2a minus x is equal to f of x. So we can apply this property. So now I will get I is equal to, okay, twice integral 0 to pi by 2. 2a is pi. So the a is pi by 2. 0 to pi by 2 log sin x dx. So actually this part is something similar to the example sum, only this 2 outside the integral is the extra for us. So let me mark this step as 3. So first this sum you have to understand in stages because it is a big sum having too many properties. So let me explain up to this stage first, and if you understand it clearly I will go further. So first this is the given sum, you are marking it as 1. Use the property integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. So you get here log 1 minus cos x because cos pi minus theta is minus cos theta, right? Now you are adding 1 and 2. So you get 2i is equal to integral 0 to pi log 1 plus cos x plus log 1 minus cos x. Now you are using one log rule. Log a plus log b is equal to log ab. So you get here log 1 minus cos squared x, which is sin squared x. Now another log rule you are using, log a power b is equal to b log a. So now that 2 comes here, that is the b thing. Then 0 to pi 2 log sin x dx. The 2 you are bringing outside the integral, you cut this 2 and that 2. So you get I is equal to integral 0 to pi log sin x dx. Now we want to change that limit to 0 to pi by 2. So it will resemble the sum in an example sum in the textbook. So now I am using this property. 0 to 2a f of x dx is twice integral 0 to a f of x dx if f of 2a minus x is f of x. I am proving that. I know f of 2a minus x, that is equal to f of x. So I used that property and I got I is equal to twice integral 0 to pi by 2 log sin x dx, which I mark it as 3. Hope it is clear up to this. Now let us proceed. I is equal to 2 times integral 0 to pi by 2 log sin x dx. So we are going to proceed as in the example sum. Only this 2 is extra, let us do it. Now let us use the property integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx, right? So now I will become, write that 2 as it is, 0 to pi by 2 log sin, you will get pi by 2 minus x because the a is pi by 2 here. You know sin 90 minus theta is cos theta. So you will be getting 2 integral 0 to pi by 2 log cos x dx, mark this as 4, right? Now as usual add 3 and 4. We are going to now add 3 and 4. So you will be getting 2i, that is equal to, you have a 2 common in both. So 2 you will get here integral 0 to pi by 2. You will get log sin x plus log cos x dx. Again the same log rule, log a plus log b is equal to log ab. I think now it will be clear to you because you have done it once. So this 2 and this 2 I am cutting. So I will get 0 to pi by 2 log sin x cos x dx. This is my I now, right? Now within bracket, no, within log I have sin x cos x. There I am going to multiply and divide by 2, right? So I am going to multiply, I am going to divide it by 2 because I will be getting in the numerator 2 sin x cos x, which is nothing but sin 2x by 2 dx. Now this is like log a by b. I am going to use yet another log rule, that is, you know, log a by b is equal to log a minus log b. So now I will write the I is equal to integral 0 to pi by 2 log sin 2x minus log 2 dx. Let us split it into 2 integrals and write. So we will get integral 0 to pi by 2 log sin 2x dx minus log 2 is a constant, take that out, integral 0 to pi by 2 just dx. Now I can write the I is equal to I1 minus I2. Actually log 2 I2 I can write, I think that will be better for us. So let me write it as log 2 I2, right? So this is one main step for me. So already I have got up to 4. I will mark it as 5. Actually, if you mark like this only, it will be very easy for you to proceed to step and then come back to the previous step and substitute that. So I is equal to I1 minus log 2 I2. That is our 5. Now actually, we have to do as separate sums. I1 is a integral and I2 is another integral. We have to integrate both separately. I2 is very simple. Let us finish that first and then we will go to I1. So let me write my I2 is equal to, okay, integral 0 to pi by 2, just dx, that is 1 into dx. So I will get x within the limits 0 to pi by 2. So I will get pi by 2 minus 0. So my I2 is pi by 2. I will mark this as 6. So now only thing remains is I have to integrate I1 and then I have to substitute in this 5. Do you follow up to this? Because you already know you are using this property, you have combined, use the log rule, okay? A new log rule and then splitting into two integrals, representing them as I1, I2 and I2 is very simple. You got I2 is equal to pi by 2. Hope up to this you are clear. Now let us proceed further. Now let us proceed with I1. Just that 3, 5 and 6 I have written here because we need that. So now I1 is integral 0 to pi by 2 log sine 2x dx. Now I want only sine x, then only I can relate it to the I. So now I am going to substitute 2x is equal to t, right? 2x is equal to t. Whenever you substitute, you have to differentiate and then you have to change the limits. Remember these steps always. In any definite integral sum, wherever you use substitution, you substitute, differentiate, change the limits. Okay. Now 2x is t. If I differentiate it, 2 dx, that will be equal to dt. So dx will be equal to dt by 2. Then let us change the limits. Okay. Change the limits. Now the x limits are 0 and pi by 2. When x is 0, t is 2x, t is also 0. When x is pi by 2, t is 2 into pi by 2, so that becomes pi. So now I get my I1 is equal to integral 0 to pi log sine t I will get here. Then the dx is dt by 2. Let me write that 1 by 2 out and write it as dt. Now once again the upper limit has become now pi. So I am going to use the formula integral 0 to 2a f of x dx is equal to twice integral 0 to a f of x dx. Okay, if f of 2a minus x is equal to f of x. Okay, integral 0 to 2a f of x dx will be twice integral 0 to a f of x dx. If f of 2a minus x will be equal to f of x. Here actually the variable is t. So let me change that. Here in the 2a part I have pi, right? Then f of t I will write, instead of f of x I will write f of t. F of t is log sine t. So f of 2a minus x, that is pi minus t, that will be log sine, you know pi minus t is sine t only. So you will get that is log sine t, which is equal to f of t. So we can use this property. So we get now I1 is equal to, already there is 1 half. Now you will get 1 2, then 0 to pi by 2. Because our 2a is pi, a will be pi by 2. Then I will get log sine t dt. Cut these 2 and these 2. So now I get I1 is equal to integral 0 to pi by 2 log sine t dt. Here you can notice the limit is 0 to pi by 2. Only the variable is t instead of x. You know there is one property, change of variable property. What is that property? Integral a to b f of x dx, that will be equal to integral a to b f of t dt. That is, the limits will be same, the function will be same, only the variable will be different. So this I am going to make use. So here I can write now my I1 is integral 0 to pi by 2 log sine x dx. The variable from t I am changing into x now. Now you compare this with the 3. What do you have there? I is equal to 2 times integral 0 to pi by 2 log sin x dx. Here you have I1 is 0 to pi by 2 log sin x dx. That means the I1 is nothing but half I. Okay, you are getting I1 is equal to half I. Mark this as 7. That's all. Now we have done our I1. We have done our I2. So now let me go to this step. That is step 5. So I is equal to, in the place of I1, let me write half I minus log 2. What is I2? I2 is pi by 2. Okay, don't cut this 2 and that 2. That log 2 is different. You can write pi by 2 log 2 or put a bracket. So bring this half I this side. So I will get I minus half I. That will be equal to minus pi by 2 log 2. I am writing this first. I minus half I is nothing but half I. That will be minus pi by 2 log 2. You can cut this 2 and this 2. So your I will be minus pi log 2, and this is the final answer for you. So see in this sum how many properties we used and how many log rules we used. So if you understand this sum, you will be clearly understanding the properties and log rules and how to use them in a sum. Thanks for watching the video. You can click the bell icon to get notifications of further videos. You subscribe to the channel also. Thank you again.